Storage vessel level control in a once-through boiler, part 3. This is part 7 of the lecture series on once-through boiler. This lecture is in continuation with the earlier lecture, Storage Vessel Level Control in a Once-Through Boiler Part 2. It is hoped that this lecture is going to be useful to you. Please press like. Please subscribe. This table appears to show a simple relationship between the feed water and circulation flow at low loads. They add up to 35%. The feed flow through economizer logic follows the boiler demand or a minimum of 35%. Here is the control block which follows either the feed water demand as per the load or the minimum limit corresponding to the Benson flow or 35% of the load. When the load is 25%, circulation flow is 10%. The set point for the controller is 35%. So an extra 25% is required to satisfy the set point. As the Benson flow is critical to protect the boiler, it follows that the boiler must be tripped on low economizer flow. Typically at 90% of the Benson flow, an alarm is raised and the boiler is tripped. Sometimes a small time delay is included to allow the standby feed pump to start. As the load increases, the circulation pump is tripped either on low storage vessel level or if the load rises above 45% BMCR. Circulation flow controller. In normal operation, below the Benson point, the circulation flow, this circulation flow transmitter is here, number 8. The circulation flow is controlled as a function of the storage vessel level. This is the level transmitter for storage vessel level, component number 6, and from here the signal is going to the function block generator. So 7 is the function block generator. So the level transmitter is going through the function generator and the function generator is determining the set point for this circulation flow controller. So the set point and the flow signal are being compared here, and this P plus I controller is controlling the circulation flow. A typical function curve fx is shown in figure. From here in this graph it is clear that up to 2 meter the circulation flow shall be 0, and as the level increases beyond 2 meter the circulation flow is increasing. So here we can see that at about 6 meter 35% of the circulation flow shall be achieved. So this is the function fx curve in this graph. Typical storage vessel pump start, stop and control ranges are shown in figure. So in this figure we can see that if the level drops below 2 meter, the circulation pump shall trip, and if the level reaches little above 2 meter, the circulation pump is given permission to start, and beyond this 2 meters and just below 6 meter we are having the pump control range, which decides how much of circulation flow will be there as governed by the P plus I controller. And above 6 meter the dump valve 1 shall open, and little further rise of the level shall lead to the dump valve 2 opening. Request: it is hoped that this lecture is useful to you. Please press like. Please subscribe.